So I did put the graphs on these. So here, let's look at using the graphs to find out when it's speeding up or slowing down. Since this is the position, I first need to draw the velocity. So I'm going to draw it here because I know I need to compare the velocity and the acceleration, right? Okay, so let's go here. So I see the slope is 0, the slope is 0. You know that means here at 4 and here at 6, right? That it crosses the x-axis, velocity is 0. So before 4, it's positive. And then between 4 and 6, it's negative. And then after 6, it's positive. So that's the idea of what the velocity looks like. So moving forward, if I want to graph the derivative of this, I purposely put it right in between. Looks like at 5 is where the slope is 0, right? So right there at 5, before 5, the slope is negative, and after 5, the slope is positive. So there we go. So now we do the same thing we just did. So if I'm looking for speeding up or slowing down, I'll just put the categories down, and then we'll just go back and check out the positive negatives. So this here is a positive y value. Oh, before 4, I see this as a negative y value. So between 0 and 4, it's slowing down. Okay, so let's look at the next interval. So between 4 and 5, this is negative. Oh, and between 4 and 5, this is below the x-axis also. So between 4 and 5, it's speeding up. Then if we look at between 5 and 6, this is below the x-axis. Between 5 and 6, it's above the x-axis. So between 5 and 6, it's slowing down. And then if I'm looking at after 6, it's above the x-axis, it's above the x-axis, so 6 to infinity, it's speeding up. So making sure, just one more time, making sure you really know you need the velocity and the acceleration. So using the graph of velocity, I know the slope is 0 here at 3, so I know it's crossing here. Positive slope before 3, so that means it's above the x-axis. Negative slope after 3, so it's like this. All right, so let's label our categories. So we're going to be doing speeding up and slowing down. Okay, so let's look at what we've got here. So between 0 and 3, this is above the x-axis, this is above the x-axis. So between 0 and 3, it's speeding up. Then if I'm looking at between 3 and 6, this is above the x-axis. Oh, that's below the x-axis. So between 3 and 6, it's slowing down. Then after 6, it's below the x-axis in both cases. So from 6 to infinity, it's speeding up. Okay, so here are the steps to find how far a particle travels. So this is the position function. So you first want to find when the particle is at rest. So that means find when the times where the velocity is 0. So you know the velocity is the derivative. So 2t minus 2, set that equal to 0. I get t equals 1. Now let's use 1 into the original function. So s of 1 will tell me where it's at. So I get 1 minus 2 plus 2, so 1. Okay, so it's, let me just color code it here. It's this one that's on the ruler. So I'm going to put 1 right there. And then I have to label the dot with it. This is, I'm using time 1. Okay, let's go back and see what else they give us. So they give us the time interval -1 to 3. So I have to go find out where it's at time -1. So where it's at time -1, I put it into here. So I get 1 plus 2 plus a 2, so I get 5. So I'm going to put 5 right here, right? The y value is on the ruler, and I label that as t is -1. The last thing I need to do is find out where it's at time 3. So plug 3 into the original guy. 9 minus 6 plus 2. So I get 5. Okay, so that means, oh, that same number 5. So it looks like it's right there. So I have to, I'm just leaving space in between it so I can see where it's at. So let's see. I'm counting footsteps, right? So let me get green here. So I start here and I draw the path and I draw the path. So from here to here, there's 4 footsteps, right? And then from here to here, there's another 4 footsteps. So the total distance is 8. So let's finish this one. So again, we find out where the velocity is 0. So 2t minus 3. Set that equal to 0. So I get 3 halves. I get to plug 3 halves into my original function. Fractions are your friends, remember. Minus 3 times 3 halves. So I get 9/4 minus 9 halves. So that gives me a negative 9/4. Okay, so this is the y value that we put on, or that's what we use on the x-axis. So I'm going to put negative 9/4 here, put the dot, and say that that's time 3 halves. So then I'm going to be plugging in my initial time, which is 0. So s of 0, that gives me 0. So here it is. And so this 0 is this 0. So I put a time 0. And then I'm going to do one last thing and find out where it's at time 5. So if I plug in 5, I get 25 minus 15. That's 10. So it's way out here. Can't draw it to scale, but this would be where time 5 is. Okay. Oops, I can't move my page up. So let's come up here to find out what the distance traveled is. So it starts at 0, goes back to 9/4, and that's at time 3 halves, and then goes to here at time 5. So this distance here is 9/4 steps, right? And then this distance here, if I just go from here to here, that's 9/4 steps, right? I'm taking positive 9/4 steps. And then from here to here is another 10 steps. So that's the total distance covered.